Okay, last week we were looking at minerals. Remember, minerals have 5 things that must be true. They must be natural. They must be solid. They must have a formula. They must have crystals. And they must be inorganic, no life. And then the next thing we looked at was that a lot of minerals are made of silicone and oxygen, and they belong to a family called the silicates. We then looked at tests. How can we test the minerals to see what they are? And I started with 3 tests last week. The first test was color. We saw that minerals have lots of different colors. Here's pretty green and pink and yellow and purple. Lots of colors of minerals. But remember, that's not always a good test because sometimes minerals have the same color, and color does not help us very much. Or sometimes they have very different colors, but they're the same. The next test we looked at was luster. Luster was the test. And we looked at whether or not a mineral was metallic, shiny like a metal, or non-metallic. And if it's non-metallic, there were different types. This is one of the non-metallics, and it was called vitreous. Vitreous, light can pass through it. We had dull or earthy, kind of ugly. Okay, so that was the next test, luster, how the light hits the mineral and what it looks like. The next one we had was crystal shape. And we know that some minerals form very easy to see crystals. This one's a cube, right? Looks like a cube on all sides. That's its crystal shape. Okay, today I'd like to do 2 more tests. 2 more tests. It is called the hardness test. Hardness, right? How hard it is. But what we're really talking about is, can we scratch it? Scratch. Resistance to scratch. Does it scratch easy or is it difficult to scratch? The hardest substance on earth is a diamond. The only thing that scratches a diamond is another diamond. They use diamonds to cut diamonds and to polish them. But I don't have diamonds because they're very expensive. My wife has a few. I do have the softest mineral, and it is called talc, and it's a little bit slippery. It feels like soap. And talc is really cool. You can scratch it, right? If I take a mineral and I want to scratch it, oh yeah, I can leave scratches all over that. But if you take talc and you crush it down, you get a powder. And the powder feels like baby powder, very soft. And then I have the hardest common mineral. Common means we have a lot of it. It's everywhere. And this is quartz. And quartz comes in lots of different colors. But you can see quartz is in the picture. That's beautiful quartz crystal. It's in, we call a hexagon shape. Hexagon crystal instead of a cube. All right, so quartz is very hard mineral. It scratches almost all the other minerals that I have. It's one that we find almost everywhere because it is sand, silicone and oxygen. Remember the tetrahedron? 1 silicone, 4 oxygen. Well, this is silicone and oxygen. It is the simplest silicate, and we have lots and lots of it. Quartz. All right. So we can take some minerals. A guy did this a long time ago. His name was Mohs, Frederick Mohs, M-O-H-S. Frederick Mohs took some minerals and he scratched them together. He took talc and he scratched it with gypsum, and he saw that gypsum scratched talc. So gypsum is harder than talc. And then he took calcite, and calcite scratches gypsum. It leaves a scratch on it. And so calcite is next. And then he took fluorite, And fluorite scratches, big scratch there. Fluorite scratches calcite. So he put them in order, right? This one is harder, 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 until he got all the way up to diamond. And he gave them numbers. Talc is 1, gypsum 2, calcite 3. And when he got up to topaz, there were no more minerals left. There was only corundum and diamond that were very, very hard, and there were none to go in between. So diamond is much harder than everything else. There's a big gap that you can see on the chart. I have some tools. I have a nail, which is iron. I have a piece of glass. I have a penny, and I have my fingernail. And we can take a mineral. Let me pick one here. I think we'll go with this guy. Okay, let's say I do not know what this mineral is. So what I'm going to do is I'm going to start at the top where we see a piece of glass is 5.5. And I'm going to take that piece of glass and I'm going to rub my mineral on it. And does it leave a scratch? And you can see there are some scratches on there, but none from this mineral. So if it does not scratch the mineral, it's less than the glass. The glass is 5.5, so this is lower than 5.5. So what I do next is I go to the next tool, which is iron. The nail is 4.5, and I don't use the tool to scratch, right? I don't scratch the mineral. I don't want to ruin the mineral. I take the mineral and I try to scratch the nail. Now look at this. It left powder on the nail. That's kind of cool, but did it leave a scratch? No, the powder rubs right off. And so no scratch on the nail. So which is harder, the nail or the mineral? The nail is harder. So this is 4.5 and this is lower. So I go to the penny. Does it scratch the penny? The penny is 3.5. Oh, it left powder again, but no scratch. So this is lower than the penny. Does it scratch my fingernail? It does not. This is lower than the fingernail. So it turns out this mineral is a 2. This is actually gypsum, which is number 2 on the chart. All right, so let's try one that's not a 2. Let me find something in the middle. Okay, here's one. Does this mineral scratch the glass? No. Does it scratch the nail? Nope. Does it scratch the penny? Oh, it does. Do you see that? It scratched the penny. Left that big mark in front of his head. Okay, so this one is between the penny and the nail. So if the penny is 3.5 and this is 4.5, the mineral is 4. This is a 4. Okay, so you see where the mineral fits between the tools. Is it more or less than the tools? That's the hardness test. Okay, test number 5. Test number 5. We got color, luster, how the light hits it, crystal shape, hardness, and number 5 is density. We can measure with water how dense the minerals are. Sometimes that helps us out. In fact, it's a very accurate test, very good test, if you have a pure mineral, nothing extra on it, if it's clean. Okay, so I just want to tell you a quick story about the density test. And it's this old guy, ancient Greek, his name was Archimedes. And some of this story is probably made up. It's probably not true, but I like this version. So Archimedes worked for the king. And the king came to him one day with a gold crown and said, our enemies gave us this crown as a sign of peace. They want the war to stop. And Archimedes said, that's great. What's the problem? And the king said, I think it's a trick. I think they're giving us fake gold. Remember, we have something called pyrite. Pyrite is fool's gold. He says, I think that the crown might be fake. And they just want us to think the war is over, but they're going to attack us later. And he said, can you prove if it's real gold or fool's gold, pyrite? And Archimedes said, sure, I can scratch it because real gold is soft and hard, and fool's gold is much harder. And the king said, no, I don't want you to scratch it. Then it's not as beautiful. You would ruin the crown. And he said, well, I'll have to think about it. Can I borrow the crown for the day? And I'll think of a way to test it. And the king said, yes, but I need your answer by tomorrow. So Archimedes thought all day of how he could prove if it was real or fake. And so he got tired thinking about it that day, and he said, maybe I'll take a bath just to relax and free my mind to think about it. So Archimedes took the crown and he put it on his head in the tub, hoping that it would help him get an idea. And he got real sleepy and he started to fall asleep in the tub. And all of a sudden, his head fell down and the crown splashed into the water. And Archimedes jumped up, grabbed the crown, ran out in the street with no clothes on, and he said, Eureka, Eureka, which means I found it, or I got it. And he ran to the king and he said, the crown is real gold. Now, what did he actually figure out? Well, he figured out what we call water displacement. When the crown falls into the water goes up. And so that allows him to know the volume, how big the crown is, how much space it takes up. And they had scales back then, balances. So he weighed it. And if you know the mass divided by the volume, you know the density. And so he was able, without scratching the crown, he was able to find the density and prove that it was real, because pure gold has a density of almost 20. It's one of the most dense materials on Earth. And fake gold has a density of much, much smaller. So he was able to prove that the crown was more dense and was real, and the war was over, and everybody celebrated. Now, remember, we have minerals that are metallic and non-metallic. It turns out that the metallic minerals are more dense. They sink, and the non-metallic minerals are lighter. They're made of silicates, which are lighter materials. That was only 2 tests today, but that's a lot of information. So we will do a couple more tests tomorrow. Bye-bye.